Now we talk about a different type of graph. This is called a weighted graph. So a weighted graph G has three parts, V, E, and W. So V is the set of vertices as before. E is the set of edges as before. Now W is a weight function that assigns a numerical weight to each edge. That is, W is a function whose domain is E, right, the set of edges, and whose codomain is R, and here I mean the set of real numbers. So here's a picture of a weighted graph. So we have vertices A, B, C, D, and E. And each edge, there are some edges, and then each edge has a weight. Okay, and you can think of this weight as representing the cost of this edge, or so for example, if maybe this graph represents the amount of time it takes to travel between cities, or whatever, not cities, between a few different locations, let's say in hours. So if I want to go, if I want to go from D to B, I can travel this way, or I can travel this way, or I can travel that way. So there are different weights for each path. So, but the point is, each edge has a weight. So we have a weight function that tells you, given an edge, what the weight of that edge is. So, for example, W of the edge C comma E, so that would be this edge here, the edge between C and E, that is 2.5. So the weight of that edge is 2.5. Right? But in general, it's a function from the set of all edges to the set of real numbers. Now, if we have a path in a weighted graph, the weight of a path is the sum of the weights of its edges. So here are two paths from D to B, okay, starting from D going to B. So you can go in a few different ways, but one way is DCB. So that's 2 plus 5. So the weight of this path is 7. Another path is DCEB. So that's 2 plus 2.5 plus 2, so that's 6.5. So if I want the path of the lowest cost from D to B, that would be DCEB. Even though I have to make fewer stops if I do DCB directly, but the weight is more. Anyways, that's just it's just a few different concepts involving weighted graphs, and that is all for that.